This module is about content mining in social media. Before we get into this module though, a couple of updates about class logistics. So first, the semester project 2, your data collection report, was due on October 12th. Remember, you have a few days to get it in before you have no opportunity for points, so if you haven't done so, please get this in. If you have any issues, by all means, reach out to me and we can discuss. The next assignment in your semester project is the intermediate report, which is due at the end of the month. It's about 2.5 weeks from now. Regarding assignments, assignment 2, most of you have completed. I've reviewed them and I'm in the process of grading them. And as with assignment 1, I'm quite happy. Thank you all for listening to my comments about word clouds and updating accordingly. Overall, in terms of the popularity of the publication, it looks like we're getting a good number of reads, which is nice to see. So remember, part of the value in the Medium post is that you get to communicate what you're doing and what you find interesting about the class to a broader world. You get to take these opportunities to create a portfolio that you can then show to future employers or show to potential graduate programs or wherever you're going in the future, and show these are the kinds of things that I did and found interesting. A point about this, though, is that when you are writing these articles, remember you're writing them for an audience who's not necessarily the most technically savvy, and you need to somehow convince them that what you are writing is interesting and worth reading. So part of the grading rubric includes a motivating question that sort of hooks your reader. And that's an important thing, is you have to give them a reason to care about what you are writing. And this is an important kind of thing to keep in mind for academic writing in general. Even when you're writing for an expert audience, or you're writing for a conference or for a journal, you need to give the reader a reason to care, a reason to think about why what you're doing is valuable to them. Are you solving some problem for them? Are you exploring some contradiction or inconsistency with the way we do things? What is interesting about your work specifically? And that may not be why you did the work, but it's important that you frame your work about why somebody needs to care about this. Note that assignment 3 is due next week. If anybody has any issues with the deadlines, let me know. We can adjust accordingly. Your ethics presentations have gone pretty well so far, so thank you very much for the people who have provided their presentations and for the people who have engaged in discussion. And now let's talk about content mining. So the main objectives for this are fourfold. One is to define at least 3 content mining tasks. Describe and define sentiment analysis. So sentiment analysis is kind of an interesting set of research. It's hard in a way that we may not expect. We'll define it in this module, or this half of the module. And it's such a common task that I would be remiss to not introduce you to it, even though I think oftentimes sentiment analysis gets abused. And then we'll talk about defining precision recall and F scores for doing evaluation. And at the end of this, you should have the ability to implement at least one content mining analysis pipeline. Now note, we're not going to go through everything this one set or in this one week of the module. I have at least one more week of content to go over that I'll talk about at the end of the lecture today. As with last week, I've assigned 4 readings. Each one demonstrates a particular content mining problem. In the first one, this is a paper by Nick Diakopoulos and Mumunda Chowdhury and Moore Naman that's looking at a system for identifying eyewitnesses on social media in the aftermath of some event. It's called the Sorcerer system. The really valuable thing here is that you get to see sort of an end-to-end development and evaluation of a system that integrates different types of content analyses. So we'll talk about some of the things that come up in this paper probably next week, but it'll give you some sense about how these kinds of technologies get used. The next post is another one from Mumunda Chowdhury and some colleagues about analyzing the post language. So this is a really good paper that was the foundation for a paper that ended up winning Best Paper Award at ICWSM in 2017, where Munmun and her colleagues looked at the kinds of language that interact with mental health content on social media, which is a super important topic. The third paper is about scaling up integrated structural and content-based network analysis. So this is by Goldbeck et al. The idea is here they take a graph mining approach and they improve upon it or show how it can be improved using content mining. It's a good sort of marriage of the content from last module and the content from this module. And then lastly is an interesting sort of separate kind of analysis. So when we talk about content analysis, that doesn't mean it just has to be text, though a lot of what we'll talk about is text mining. A lot of the content mining that's out there is text mining. Images also play an increasingly important role in how people use social media. And here is a paper from this year talking about how specifically Russians and state-sponsored disinformation operations used media or imagery in their social media campaigns. All right, so take a look at those. As with last week, they're not required for you to have read them before you go through the lecture, but they are good examples of the kinds of analyses you might do for your content mining analysis assignment. And it'll give you some sense of the kinds of research problems that people do in this space and how they get addressed. So now let's talk about some motivating questions for content mining. So you might want to ask, given a lot of social media data, how do people feel about a given company or a given political candidate or an object that you're trying to sell or a particular topic you're interested in? Or what patterns of descriptions can we find in how people talk about COVID-19 symptoms? Or when people are talking about COVID-19, if we're trying to do some interventions for public health, and we want to understand what kind of misinformation is being shared and how popular are different types of misinformation. Because there's a lot of different kinds of misinformation around COVID-19, topics about where the virus originated from. Was it grown in a lab? Was it a naturally occurring issue? Was it planted by the Russian government or the Chinese government or the American government? There's a lot of conspiracy theories around this that sort of mask the natural source of the virus. But understanding those kinds of topics and how popular those are versus topics around the use of bleach or hydrochloroquine or some other home remedy for addressing COVID-19 from a curative standpoint, those are two very different kinds of topics of misinformation. And you may really want to intervene on misinformation that's about how people can protect themselves from the virus. Maybe you care less about intervening on the kinds of misinformation about who is responsible for the virus, because maybe who is responsible has less impact on controlling the spread of the virus, whereas how people protect themselves or the preventative measures they take have much more impact on the spread. Same thing, maybe you want to understand where people are when they're posting their COVID-19 symptoms. So several years ago, Google released a paper called Google Flu, or a system called Google Flu, where they tracked the spread of the flu in the United States and in the UK using search terms, or how people were searching for symptoms. There were some issues with that have grown over time, but you could ask the same kind of questions about COVID-19 as well. You may not get very fine-grained data, but you can still ask and see things about geographical trends or maybe kinds of some kind of information about the locations of people when they post about COVID-19 symptoms. Stepping away from COVID-19, we can also ask questions about imagery. So what kind of images get a lot of engagement online? It's important if you're doing social media marketing or, as I suggested with the disinformation campaign paper, if you're wanting to do online influence. A lot of work that I've done has been on how we can use social media in the aftermath of crises. So in particular, we're doing content mining to understand when people are looking for search and rescue, when people are asking for help. We have a lot of content around these events, and these are the kinds of questions that we can ask it, that we can try and solve with content mining. Other examples is in the lead up to Brexit, you may ask, well, how is social media responding to this topic? Are there a lot more conversations about the UK staying in the EU or leaving the EU? Here, this shows there was a lot of use of the hashtag Brexit compared to relatively less use of hashtag StrongerIn in the lead up to the Brexit referendum. Now, social media has the opportunity for manipulation and has a lot of issues here, but you could have learned something about this topic just by looking at the kinds of frequencies of different hashtags over time. Likewise, there's been a lot of work on comparing Twitter and the stock market. I know at least one of the Medium posts from this class has looked at Reddit and the stock market. This is actually quite popular, and what we've seen, I think this has come up in several of examples, in some of the examples I've given before, that Twitter does in fact have impact on the stock market when, for example, the Associated Press posts or gets hacked and ends up posting a fake tweet or a incorrect tweet about an explosion at the White House. A lot of high-frequency trading companies and automated trading companies use social media as one of the many signals when they are identifying what they want to buy and sell, or when they want to buy and sell. As I've already mentioned, looking at how social media responds to crises, there's papers about understanding terrorist attacks on Twitter. This is kind of an interesting case, especially with terrorism, because one of the goals of terrorism is to instill fear in a population and drive behavior. So by looking at how people are responding to terrorist attacks online, you get some sense of this response. There's been other work on looking at the drug epidemic in the United States and looking at different states that have higher than expected prevalence of mentions of heroin or mentions of particular drugs. We've already talked a lot about ideology, so when we talked about graph mining, in content mining, you can do a similar kind of thing based on language. It turns out that people who are on different or who have different political affiliations use different language when they're discussing items or discussing people. There's been a lot of work on polarization for online discussions that can be driven by content mining questions. If you are looking for sort of less politically charged things, definitely how people talk about different food items or different life experiences in rural versus urban locations has been an area of study here about how people in urban areas talk more about coffee, beer, and wine, where people in more rural areas talk about pizza, chocolate, and ice cream. It's kind of an interesting dichotomy. There's been a friend of mine at the University of Bergen, I believe, does a lot of work on recommendation systems for recommending more healthy food options. So maybe you would want to use this or integrate these kinds of signals into some recommendation system that gives you insight or gives your users insight into what are healthier options that still align with the kinds of foods that you may be interested in. So those are examples of how content mining is used, or the kinds of questions you may answer with content mining. To put this into perspective with what we talked about last module, when we talked about graph mining is much more about learning about attributes, structure, and flow of interactions, where we have these nodes and edges, where nodes represent entities or people or objects of some form, and edges are their interactions. And we can learn things about the objects in this graph, or paths through the graph, how people interact, or how these entities interact in a large-scale way, how they group together, these kinds of things. In text mining, we can learn things about the communication or the messages that are shared in these graphs. So a lot of things can be, or a lot of problems can be viewed both as a content mining problem and as a graph mining problem. Ideology is one of those that we've already talked about. But there is some distinction here. So with content mining, we care a lot more about the message and trying to understand something about the message. There are different data types that we can mine for content mining. So a lot of it that we'll talk about is primarily around text, but you can also do content mining for images. So there's a lot of more recent work about how images get used in the aftermath of crises. So here is a mashup of two images in the aftermath of terrorist attacks that were shared on social media essentially right after the terrorist attack. The one on the left is the Brussels airport bombing, and the one on the right is the Boston Marathon bombing. You can also mine the metadata, so the sort of data about your data here. So this is an example of content that's pulled from the Twitter JSON structure, so we can see things like favorite count and retweet count. We can learn how engaged people were with a particular message based on this, by mining this kind of metadata. But there are a lot of questions here. Note that the kind of distinction between what is text and what is images, or what is text analysis or text mining, image mining, and analyzing metadata, they're not very always very clear distinctions. So when we talk about emoji, for instance, are emoji text or are they image data? Now, generally we think of them as text. They look like text or emoticons in the same way that they get embedded into messages, but they are in some sense different. A lot of you in your Medium post talked about filtering special characters or non-ASCII characters, which means that you get rid of these. But what does that mean for us? So if we're trying to understand something like Black Lives Matter or support for Black Lives Matter, you could imagine that emoji like this provides you with a lot of signal, even though they have potentially kind of a feel of imagery. So yeah, emoji for things like sentiment or for things like social movements can provide a lot of signal for support. So yeah, as I mentioned, when you sort of by fiat decide that you're going to delete special characters or Unicode characters from your text analysis, you should be aware that you're throwing away potentially high signal things. So here there's a risk, which is why you'll see this image pop up a few times about here be dragons. You should be careful when you do these things. Not to say that deleting special characters or Unicode characters is always wrong. It depends on what your task is, but you should be careful. You should have a good reason to do these things. All right, so those are some examples of text mining, right? But you can also mine images. So here, this is a beautiful image. You may ask, well, where was this photo taken? I'd love to go to this place. But with just this image, how do you figure that out? Well, it turns out that with a lot of imagery that's shared online, they have embedded metadata called EXIF tags. And EXIF tags can tell you a lot about the imagery, both the kind of camera it was taken on, data it was taken on, but also the GPS location if the device that took the image has a GPS capability, which many phones do. So many phones actually embed GPS coordinates into your images. Now, oftentimes it gets stripped out when you post images to Twitter, for instance, but other platforms like Flickr don't extract or clear these tags, and they can be used for mining. So it turns out this particular image has an EXIF tag that says the latitude, longitude, and altitude where this image was taken, and it's from Iceland. We can pull this out and see. So for this part of the module, though, I'll primarily talk about text mining, and we'll talk about 4 different areas of this. First is about simple tokenization, then we'll talk about sentiment analysis and emotion, then topic modeling and geolocation, named entity extraction, and a few other sort of text-related tasks. For this part of the module, this week, we'll only talk about the first 2. Before that, though, note that content mining, specifically text mining, is part of a much larger field than just content mining. So it steals from data mining, or is part of data mining, relies heavily on natural language processing, takes from information retrieval, which is about how we build search engines, takes from information extraction, which is about building knowledge graphs and extracting facts and information from text or from content. So definitely there's all different kinds of research areas that get touched upon here. And for time reasons, I can't go into all of them, and certainly there's way too much to go into all of them. There are whole classes and fields about NLP and IR and data mining and these kinds of things. But just note that this is part of a larger context or a larger field of study. All right, for simple tokenization, let's talk about some motivating questions. Maybe you want to know what the most common hashtag is that is shared by a particular community. This is a question you may ask for assignment 3, because assignment 2, you did some, or I guess assignment 4, right? So for assignment 3, you do some graph analysis and identify some community, and then you want to figure out, well, what is that community really talking about compared to some other community? So let's look at the most common hashtag that's shared by people who participate in this community. Or maybe you want to know, well, who is the most retweeted or mentioned person with a given hashtag, or from a given community as well. So you do some filtering and say, well, here are all the tweets from a given community, or include some hashtag. Who are they talking about, or who gets retweeted the most? How do we compare these two things? And finally, what website gets the most links during the weekend? Maybe you're trying to do some analysis about when's a good time to share my link to my video or my link to my website if I'm doing marketing or sales or something like that. You can go look at the social media data that you've collected and try and get at this question using relatively simple or straightforward methods. All right, so when we want to know what the most common hashtag is, we have some tweet, right? Clearly this tweet has hashtags, but we can't just throw this tweet sort of by itself or take this tweet sort of by itself. We have to do something to it to extract these hashtags. So this is called pre-processing our data. So what this looks like is generally we want to take this tweet and we want to extract all these words from them. This is called tokenization. So often the first thing you do is take some tweet and split the tweet up into these individual tokens. So in Python or R or whatever language you use, maybe the first thing you think about is just splitting on white space. So here's an example of this. We have that tweet text and we call split on white space. And we get back these keywords, learn more about, etc. This works decently well, but we run into a problem where now our tokens assistants or hashtag Hillfire have these punctuation marks after them. Do we really care about that? Is assistants with a period at the end different than the token assistants? If we're looking for hashtags like campfire or Hillfire, we probably want to not include those punctuation points. So again, there's some complications here. So how do we deal with this? Now, the first thing you may think of is, all right, let's just go through and remove all punctuation from the tweet. That seems like a reasonable thing to do. Python makes this relatively easy with translate, but now by doing this, we've accidentally removed the hashtag symbol or the octothorpe or the pound sign. Now it's sort of unclear based on this analysis what was a hashtag in our data. So we have to pay attention to that as well. It turns out in Python, there's the natural language toolkit, which provides some tokenizers for this. Tokenizer is the general name of a tool that does tokenization or splits text up into tokens for you. So here, this is an example of using the casual tokenize function, which is generally, I think for a long time, was referred to as the tweet tokenizer, because tweets have a lot of interesting sort of oddities that maybe your general news literature doesn't have. News may not be using hashtags. So yeah, you can call casual tokenize on tweet text and rely on these sort of other libraries to help you do this tokenization. But even then, this doesn't really completely solve the problem, because here we see now we have this additional token for a period, which is nice. So the federal assistance period, we get 3 different tokens here, one for federal, one for assistance, and one for the period. But how do we handle these additional punctuation tokens? Now, one strategy for this could be just drop tokens that are comprised of punctuation, but then we drop potentially emoticons. Now, maybe you don't care about that, which is fine, but if you're doing something around sentiment analysis, maybe you care about these kinds of things, because they tell you something about whether the people are happy or sad, or the authors are expressing some sort of positive sentiment towards something or negative sentiment towards something, which you can potentially see from these emoticons. So another thing you may do then is, well, let's drop tokens of length 1. Now, in some cases, this might be okay, but in other cases, we have ellipses or people using multiple runs of these punctuations, which is actually very common in Twitter. One aspect of this is from natural language processing, where you perform a process called normalization that reduces these kinds of repeated runs. But maybe you can still drop tokens of length 1 and not hugely worry. So you'll have this, you'll do some normalization, you get rid of these ellipses or the multiple question marks, and you can drop them. But what about single letter words like I, or in Twitter, you often see things like you, just the one letter? Are we going to drop those as well? And the answer here is really, it depends. It depends on your task. It depends on what you're doing. If you are just trying to count up hashtags, then really none of this matters. You can just look for tokens that start with the octothorpe and throw away all other things. Oftentimes, really low length tokens get thrown away anyway, because they're not they end up being very common and maybe not high signal, but maybe sometimes you do want to keep them. So it depends. Other things you have to worry about are capitalization. So here in this example, I may ask, well, what's the difference between hashtag Hillfire, where the H and the F are capitalized, versus hashtag Hillfire, where it's all in lowercase? Now, in this particular case, maybe it doesn't matter. So you may as part of your pre-processing, go through and lowercase all of the text in your tweet, which would work in this case because these things are probably the same. But if you're trying to do sentiment analysis or trying to understand the sort of tone of a particular message, then I'd say there's probably some significant difference between yay, or the word yay, that's all in caps, and something that's all in lowercase. That tells you something different, or at least from a human's perspective, they'll pick up on different markers or cues in the capitalization of the message. And then that's not even to mention the possibility of lowercasing a URL, which then breaks the URL. So these are things that you have to think of when you're dealing with tokenization. So again, it depends. So what we've seen here is we have talked about some methods for doing this tokenization process, and you pull out these single tokens. Whatever additional steps you may have to take in order to do some cleaning to get just the tokens you want is a thing that you'll have to think about. But generally, though, you get these tokens out. These tokens are called unigrams. But you can have additional kinds of tokens, so you can do these sliding windows down the tweet or down your message, and you can create what are called bigrams. So they're actually pairs of words that appear next to each other, which is useful if you're trying to get at more important phrases, because oftentimes if you just do assistance, maybe you want to differentiate between federal assistance or local assistance, but you can't necessarily do that if you are just treating all the words individually. A better example is oftentimes comes from location, where the tokens New and York or New and Jersey mean something very different alone, but if you put them together, they give you some idea of a location. You do the same thing with trigrams as well. In a lot of examples of text analysis, you'll see unigrams, bigrams, and trigrams get used. Again, it depends on what you're doing, but these are different options that you can use when you are doing your tokenization process. I'll note, though, so when I talk about examples of hashtags and tokenization, you actually don't necessarily need to do this if you're looking at Twitter data, because Twitter data actually provides you hashtags separately as its own set of metadata. So if you go look at the JSON for a given tweet, you'll see this entities entry, which has a listing of hashtags that specify the text. And note that the hashtag potentially will be lowercased here. I think it actually maintains the capitalization that that the author puts in. This is something to pay attention to. Same thing with user mentions or other kinds of entities, URLs, etc. They get embedded in the metadata of the tweet. So in some sense, if you're only looking for this kind of information, you don't have to care so much about tokenization. But if you're looking at Reddit data, especially Reddit post information like self-posts or comments, you don't have that information. You don't have that pre-processing done for you, and you will have to look for or have a method for tokenizing that data yourself. So when we get back to the motivating questions here, what is the most common hashtag shared by community? Now we have a way of extracting and counting up these hashtags. Who is the most retweeted or mentioned person? We have a way for doing that. You look for usernames that have the @ symbol before them for mentions, or you go just pull it from the metadata, but you can do that. But if you want to look at the website that gets the most links during a weekend, so now we've talked about you can tokenize up the tweet and extract a website or extract a URL and pull out the domain. We haven't really talked about the time aspect. How do we get links during the weekend? So I'm going to do an aside here and talk briefly about temporal dynamics or extracting timing information from social media data. Because here, this is an example of tweets from Ferguson, Missouri during demonstrations around the murder of Michael Brown in 2014. The blue line is the total number of tweets that mentioned Ferguson or Michael Brown. The red line is tweets mentioning the bigram tear gas. The green line is tweets mentioning Obama, and the blue line is tweets mentioning Iraq. And just by looking at this information, we see what are potentially moments of high importance or high impact during this event. So briefly, how do we do this? So all tweets or all the tweet metadata that you can pull from Twitter provide a created @ field, which has a timestamp of a particular format. So here, this is Monday, October 1, 1/10/09, 2018. So note that this time is in UTC time, or Greenwich Mean Time. It has no time zone information. It doesn't tell you the time zone that a particular user was posting it. That's actually potentially located in another field. What we want to do is extract or process that time. So in Python, this becomes a date time object. How we do this is we specify a particular time format. So here, this is %A, %B, etc. And then the date time package in Python has a function for stripping times, or strip p time, or stripping times based on patterns. So then you can apply this function with this format string to these created at fields and extract what actually is the date time. You can do this in Java and R and other languages as well. But the value is, now that you have processed this time, you can go and create these visualizations of frequency for particular posts. So here, what this actually shows us is at 7 p.m. on the 13th of August, we start to see coverage of the original protest or demonstration. And then the media and conversation online ramps up very quickly. So by 10 o'clock is where we see the peak discussion about the demonstration on August 14th. By 3 a.m., this is when I believe a journalist was arrested who was covering this information, so they got a lot more coverage. And then here at the end, at 1 p.m. the next day, President Obama gave a speech addressing the unrest in Ferguson, Missouri. And we can see this information, or this information pops out very readily just by looking at the time series data from this content and the tokens that you've extracted from each one of these tweets. Now, another point about tokenization is it's used very heavily. Basically, it's one of the first steps you do in all these different analyses. So when we talk about sentiment, we'll talk about momentarily, the first thing you do generally is extract the tokens that are in a particular message. Topic modeling is all about identifying tokens that co-occur to some degree, or some degree beyond what you'd expect randomly, because they're expressing information about the same topic, so you have to have these tokens individually. Geolocation is about identifying or extracting or ascribing location information to tokens. Named entity extraction is about identifying tokens that highlight or identify a particular named person, thing, or object. So all of these sort of tasks generally start from a tokenization process. Moving on to sentiment analysis and emotion. So what is sentiment analysis? So from a very high level, it's this idea of ascribing some sort of feeling to the content that we're looking at. So here, this example, a tragic day in Belgium, terrorist attacks have killed at least 13. So there's clearly some sort of negative mood or negative emotion, some sort of negative feeling expressed here. More objective content, often content from news headlines, is also pretty prevalent. So here, Buhari reacts to multiple bomb blast incidents in Brussels, press statement from the presidency below. There's no real emotional aspect here, so you could say maybe there's neutral sentiment. Whereas here, dear friends, safe and sound in Brussels, thank you for all the kind thoughts. Now, while this tweet occurred during a tragic moment in the time frame in Brussels, you could imagine this tweet has some positive feelings to it, where this person is thanking her friends and family and expressing that she is safe. So there's some positive emotion or positive feeling here. So from a sentiment analysis perspective, or that when you talk about sentiment analysis, what we're trying to get at are these aspects of content. So some motivating questions to sort of set the stage. You can ask about sentiment around movies. Are people recommending this movie or not? For products, are people happy or sad about the new iPhone? Public sentiment, are people generally more happy or less happy, or is happiness increasing, or is positive feeling increasing or decreasing in consumer confidence in the United States or a particular country? Politics, are people for or against, or do they have good feelings or sort of positive feelings for a particular candidate or particular topic or issue, or is it more of a negative feeling? And then prediction, based on what we've learned about, or what we can extract about people's feelings, can we then make some prediction about what this means for market trends, or election outcomes, or box office takeaways from movies or television shows, these kinds of questions. Now, also seen sentiment analysis or the idea of sentiment popping up in other places. So if you ever looked at Amazon, you can see the customer reviews. This is a form of sentiment. This particular TV has many one-star ratings. This would be people are expressing negative sentiment about this television. 787 Coffee, a coffee shop near my apartment, has language that talks about great coffee, super friendly staff, fantastic and delicious coffee. So that's all expressing some sort of positive sentiment. And you can see that captured in the number of stars that have been provided to this establishment. It can also be talking about professors. So a friend of mine, Chris Mazinski, he has a very favorable rating on Rate My Professor. People talk about he's a great professor, cares about students and success. So just by looking at the message, you get some idea that people have a positive feeling towards Chris, and you can see that in the quality rating as well. All of these examples on the left have a rating with them, but you don't necessarily have to have a rating to understand something about sentiment. So here, these are comments that come from a set of videos that I often watch on YouTube when I'm working. And this, I think all of these express some sort of positive sentiment here. One smile can start a friendship. Don't know if someone is reading this, but if you are, heart emoji, prayer emoji, these kinds of things. You are unique and worth it. You are the light. All of these express some sort of positive feeling. You don't necessarily need to know what the rating is or the ranking or some score associated with that to know that there's some sort of positive aspect here. The sentiment's been operationalized and studied explicitly for understanding its correlation with the stock market. This has been a popular area of research for almost a decade now, and in fact has been somewhat debunked. In 2009, a paper was released about the 2008 presidential election and compared sentiment in Twitter to public polls, and they found some correlation here, though it's not. They didn't find like very strong sort of causal relationships saying that social media polls drove Gallup polls, but there was some connection between self-forecasts or polling data and how people were discussing content on social media or how people were discussing these candidates. Now, the world is very different now than it was in 2008 in terms of how social media is used, so this is a thing that we would be very hesitant to do now or trust now. But sentiment analysis has been used for these kinds of things a lot. So you may ask yourself, or a good question here is, what kind of language do we think denotes these kinds of attitudes here? And you should be careful to consider what sort of hazards may come up and bias your results when you use these kinds of data for doing forecasting for the stock market or for elections or for really anything. Imagine that there's going to be a population of people who are very interested in influencing how people talk about stocks online as a way to game the system. There's, especially in the world of cryptocurrency, there has been some research about pump and dump schemes where people try and manipulate social media to push some hashtag about a particular cryptocurrency. Then they sell all of their cryptocurrency, and then when the price crashes after they've done this pump and dump scheme, then they've made a lot of money and sort of exploited a bunch of people. Same kind of thing for online disinformation campaigns or public relations campaigns, where the data may not necessarily be trustable. Despite all of that, as I said, sentiment analysis is increasingly popular. It's a thing that you'll come across very often when you're doing social media analysis. And over the past 15 years, it's become increasingly popular, right? So we still need to talk about it and consider ways to do this correctly or do this well and address whatever issues may exist. Now, sentiment analysis as well is talked about or called a number of different things: opinion mining, opinion extraction, sentiment extraction, subjectivity analysis. All of these sort of mean the same kind of thing and tend to get used interchangeably, though they, in a very technical sense, may mean something different. So opinion mining may be, in some very specific way, different than sentiment mining. We'll talk about this more specifically when we say, well, what is sentiment? How do we define what sentiment is? Can we be more specific about what we're actually measuring when we talk about measuring sentiment? So generally this is claimed as sentiment measures affective state, but affective state can mean many different things. So in literature, there's a thing called Scherer's typology, which talks about the different kinds of affective states. So there's emotion, which is generally this brief but synchronized evaluation of an event. There's mood, which is not really a caused thing. It's low intensity and has relatively long duration, but it has some aspect of positive, negative mood. There's interpersonal stance, how you feel about another person at a specific moment in time. There's a personality trait. It's generally relatively stable, and it's more about someone's disposition or how their behavior typically lands. And there's attitude, which is generally an enduring aspect or an enduring sort of view of one person towards another, or another person, or another object. So if we look at Scherer's typology, it has this nice breakdown of intensity and duration, event focus, how often it changes, where things like emotion can change very rapidly, but personality traits generally don't change rapidly or don't change. Attitudes are somewhere in between. Interpersonal stances can change. The impact of behavior can change all of these different things differently. But when we talk about sentiment, oftentimes we're explicitly talking about attitudes. We want to understand something about how somebody feels towards another thing, how their beliefs are, what their preferences are, or what their dispositions are towards other persons or other objects. So when we talk about measuring sentiment, what we're really talking about is measuring or detecting attitude, meaning that we have some holder of the sentiment that we want to measure. So an individual or a community of people have some sentiment, and we're trying to measure that person's or that group's sentiment towards something. So we have some target, and we're trying to measure the sentiment that the holder has about this target. And it could be coarse-grained, like love, hate, like, desire, etc., or it can be measured in different ways. So one sense is you could think about it in terms of this line where you have negative feelings and positive feelings that come in different degrees. So you can like something or dislike something. You can love something and you can hate something. And the sentiment about love is stronger than the sentiment about liking something. The sentiment about hating something is stronger than the sentiment about disliking something. So you have this scale here. And maybe it's continuous where 0.5 says is I like something, and 1.0 is I love something. And you can go further down this scale. What we do in terms of content mining for sentiment analysis is we take some message, generally some text or some set of emoji or imagery or what have you, and we try and project that text into this scale of polarity, into some either positive or negative space, or provide it some explicit score. So now when we go back and look at the motivating questions we had, so when we talk about movies, here the holder is a public or a particular person, and the target becomes the movie. Same thing, products, the holder is the person, and the target is the iPhone. Consumer confidence, is a person or the public, and how they feel about the economy or how they feel about the target being some kind of market or general sort of stance of the country. Politics, there's a clear holder, the population, the voting population, and a target, it's a candidate or an issue. And from a prediction task, generally we would say, given some holder or some population, can we predict their stance or attitude towards these targets? And then we do that over time or use that information to then predict some outcome or some choice, some behavior that's based on that sentiment. That gives you some definition of sentiment or the kind of thing that we want to do, but how do we measure this? How can we operationalize sentiment into a thing that we can measure or an outcome that we can quantify? So one way is, when we talk about sentiment being positive or negative, is just this binary differentiation. Is something good or is something bad? Is our stance towards or attitude towards something that thing is good or that thing is bad? This is analogous to the thumbs up, thumbs down that Siskel and Ebert or Roger Ebert gave to movies. So is the movie good or is the movie bad? And maybe that's all we care about. You can get more sophisticated though. So when we talk about course evaluations, you can give more information. Maybe I'm neutral about something. I don't really have a very strong feeling one way or the other. I have a negative or positive feeling, or I can have very strong and very negative feelings. And we can quantify it in this sort of ordinal scale. Same thing, we can do other kinds of ordinal scales where 0 or 1 is generally bad, and then +4, +5 is generally good. And we can scale the things that way. And these are, in fact, realistic measures of sentiment. So as I mentioned, sentiment analysis has been around for a long time. The SimEval conference talks about this in one of their tasks, one of their ongoing tasks, task 4, where they have been looking at this question of sentiment analysis in Twitter. And they have this task operationalized in a number of different ways. So there's one version of the task where you're given some message, and all you're trying to do is classify whether that message is positive, negative, or neutral. In a more sophisticated version, you have a topic-based message polarity classification, where we have some message that includes some topic, and you're given the topic, and you can do one of two things. You can classify whether that message expresses a positive or negative sentiment towards that topic, or that topic becomes the target. Or you have a more sophisticated, more fine-grained 5-point scale like the one I showed you, where now you're, instead of just this positive or negative or binary classification task, you have a more multi-class space. And you can do this more increasingly sophisticated, where you have a set of tweets about a topic. Can we estimate some distribution across this scale? Or even can we do polarity classification across languages? And you can get increasingly sophisticated and say, well, given some message, can we automatically extract the target, the topic, and then ascribe some sentiment of that holder towards that topic as well. So this is an ongoing area of research. People still work in this area of sentiment. All right, so how do we use text to extract sentiment? So there are two general ways of doing this. The first is lexical or rule-based analysis, and the second is sort of more machine learning-based approaches. So here we have two different Yelp reviews talking about two different restaurants or two different coffee shops that are near my apartment. So you can see that top one, 787 Coffee, has words like great or fantastic or delicious or friendly. All of these things tell us something positive about the reviewer's stance or reviewer's attitude towards this establishment. Whereas in this other bagel shop, we see terrible or mess or rude, which all tell us something about how this author, this reviewer's attitude is negative towards this restaurant or this establishment. And you could imagine, well, if I was trying to write down the kinds of words that I might think about when I'm trying to express sentiment, or the kind of cues or the kind of words I would use as cues to like let me know how somebody feels, these are the kinds of things you might look for. So this idea of using Lexica to infer sentiment is basically creating rules or creating these lists of words and trying to ascribe some sort of score or some sort of metric to them that lets us then evaluate what the overall sentiment is in a particular message. So you can imagine if we have these, like a large collection of these words and scores, then all we need to do is say, given some tweet of text T that we've tokenized up into a bunch of separate tokens, and we have our lexica of words and polarity scores, D, then we just look for what's the average polarity for words in our tweet that have a polarity score. So we'll throw away things like the or and or is that don't really have any sort of meaning from an attitudinal standpoint, or they don't really tell us anything about the attitude of somebody, and say, well, what is the average sort of polarity of this message? This is a super simple, like standard kind of baseline for ascribing this kind of polarity. Now that works, but how do we deal with things like delicious versus very delicious? So say delicious has a +1 and we add some qualifier to it about very. Should we double the score for delicious? That very delicious actually should be 2 instead of 1. How do we deal with that? And if somebody says not great or this negation, do we say, well, if great is a +1 and we've identified not great, or this bigram of not great, should we invert the sign for this and say, well, great is a +1, so not great must be a -1? How do we deal with that? There's a lot of software out there that has tried to simplify or codify these kinds of decisions. One very popular one is called Vader, which is actually, I think, built into the Natural Language Toolkit in Python now. There's also Cent2WordNet. There's the Linguistic Inquiry and Word Count called Luke, or pronounced Luke, which actually has way more than just sentiment. It's got emotion and tone and all these other things. But they try and address these questions, like what kind of rules can we construct to address issues like negation, or address issues like quantification, or these qualifiers where somebody says very or extremely, or these kinds of things. How do we use those then to calculate or quantify a valid measure of sentiment? And a number of you in your Medium posts have already done this kind of sentiment analysis using the text blob package, which also is this sort of lexical-based approach that tries to codify these kinds of rules. And in fact, we can see this if you go to the GitHub repo for text blob. It, in English, has this English sentiment lexicon, which is built primarily, I think, on WordNet. So text blob then uses this lexicon and a set of different kinds of rules to try and figure out how it should put together these different words and these different scores to come up with a reasonable or correct value of sentiment for a given message. But there are issues with lexical approaches. So here is one from several years ago where Christopher Potts compared the amount of disagreement between a number of different lexica. Here what this shows is like CentiWordNet and Luke disagreed about 25% of the time in the kinds of sense or polarity score that a given word should have. Now, that's potentially quite concerning. So if we're trying to understand, well, what is your sentiment versus my sentiment towards this particular target, and we use two different lexical approaches that, you know, 1 out of every 4 words may be different, and we end up with some very divergent value of sentiment. So this is problematic for us. Now, how do you address this problem? Do you say, well, there should be some single adjudicator of what the actual polarity is, or do you have some a confidence score that says, well, if there's disagreement, then the confidence about this sentiment goes down, which is, I think, what TextBlob does. These are things that we have to pay attention to. So a discussion question for this is, what other kinds of issues do you think are likely to affect this kind of approach where we're relying on some sort of pre-made vocabulary or dictionary of terms and their sentiment? What other issues might that introduce when we're talking about doing sentiment analysis? And in fact, measuring sentiment can be hard for a bunch of reasons, beyond just the rule-based versions or the issues with the rules that I just mentioned. So for one, here's an example. I really love you, but I dislike your cold sister. Now we've got 2 different targets that are being discussed in this single sentence. How do we disambiguate what the sentiment is about a particular entity or the particular target? I love dogs quite a lot, but cats I really hate. Same kind of thing. So 2 different targets here. We have to separate these somehow. Now, there's a lot of work on doing like sentence segmentation, but that's not going to help you here. Maybe you have to do phrase segmentation. Identify these different phrases or what the different nouns are, and ascribe some sort of sentiment to each one of these nouns. Things get worse when you look at more sophisticated kinds of reviews, right? So here's an example from a movie review. This film should be brilliant. It sounds like it's got a great plot. The actors are first grade. Everything should be good, but it just can't hold up. So for the first few sentences of this review, you may think this is great, but then right at the end, your expectation about what is going to be said here is thwarted, and now the meaning of all of this, or the attitude that the author has about this movie, becomes very different than if this last line had not been added. How do we deal with that from a sentiment analysis perspective? Same thing here, where ordering may tell you something. So we have the very talented Lawrence Fishburne, but Lawrence Fishburne is not so good. So the word good would tell us something positive, but now we have this negation here that we have to resolve or reconcile with the very talented aspect. How do we deal with this ordering aspect? Another clear example where sentiment can be hard is with sarcasm. For example, this is so clearly the best movie ever written. You'll never, ever regret the minutes of your life spent watching it. So this is, if you were to hear somebody say it that way, or communicate this response or this review to you that way, it would be clear to you that this is probably a bad review, that somebody is saying this movie is not good. But if you're just looking at the language of the message or the individual tokens, you get potentially a very different perspective. So how do we deal with sarcasm from a sentiment analysis perspective? And this is in fact an open question in the field. Now, you may think all of these are relatively contrived, but if you go look at Rotten Tomatoes, these are the kinds of things that we really have to deal with. I don't think there's anything wrong with this film that doesn't really work. So there's lots of negation here that would make this confusing. An intelligent and modestly scaled thriller, even if it doesn't quite capture holiday or Hollywood days of yore, it comes desperately close. So that's kind of positive, I suppose. Aside from the sensational, continuous 20-minute opening take and amazing shots, really there's nothing very good here. So again, this is a thwarted expectation kind of question. The most aggravating kind of movie, it's got so much potential, and it's unbelievable but unbelievably disappointing. So these are real kinds of examples that we have to deal with when we're trying to do sentiment analysis. So as a result, people have come up with more sophisticated approaches for this using machine learning, where I'm not going to go deeply into machine learning because there's whole classes for this, and that's not really the substance of what this course is about. But I'll give you some sense about how sentiment analysis and sort of text classification problem comes up, because you can actually use that quite a bit. We'll talk about this in terms of a supervised machine learning model, where we have a bunch of documents here, let's say they're movie reviews, where we have text in each one of these documents. We have some polarity score. Here it's just positive, negative. You could imagine some scale here, some score. These comprise our data set. So we have a bunch of documents. They have some sort of, each document potentially has some signal of sentiment, and it has some label associated with it that tells us the kind of sentiment there is. We take all of these documents, we tokenize them, as we've already talked about. We do some other pre-processing. Maybe this is removing long runs, or removing words that we've never seen before, or remove nouns, because nouns maybe don't have a particular signal for polarity. And we generate features from these documents, and then we apply some sort of supervised machine learning model that learns what the signal is that is in these documents and their labels, and then we can predict for a new document some polarity score or sentiment label. I've talked about this being like positive and negative, as I've mentioned, but these could be scores. It could be positive, very positive. It could be multiple classes, these kinds of things. Again, I won't go deeply into all the different options here. Sentiment analysis has actually gotten a lot of work, though, from these movie reviews. So movie reviews have been around for a long time. We have whole newspaper archives that are just full of movie reviews for decades. And each one of these movie reviews often comes with some label. So here, we can look at all this text and say, well, these are clearly examples of positive instances of sentiment, because they have said they're positive. And here are clear examples of things where people are saying the movie is bad, or negative sentiment. So now can we learn some machine learning model that would take this text and produce or reproduce these labels. So how does this work? We start off with our set of all the movie reviews that we've seen. We tokenize all of these documents to identify the unique words that exist across this whole set. This gives us our vocabulary. And then, so for a particular sample, the most aggravating kind of movie, etc., we want to create some sample that we can learn from. So we create a 1 by v vector that is a row that has columns for every vocabulary word that we've seen. And we set all of those to 0 at first. And we can ascribe some label to it. So we know this is a negative sample, so we have some label as negative. Then for each word in our document, so we go through this tokenized document, we flip the corresponding column for each one of those words to 1 for every word that's in this document. So now we have this feature vector that says, well, these are the words that exist in this document. And then we can learn something about that documents that contain the word unbelievable, or documents that contain the word disappointing or aggravating, tell us something about this is likely a negative review. Now, the example that I've shown here uses a binary 1 or 0 for whether a word exists in our document or not, but you could definitely do it differently or in different ways. So for example, these 1s or 0s don't need to be binary, they could be frequencies. So how many times did the word disappointing occur in this message? Or how many times did the word bad? Because if you could imagine that a particularly bad review may say this movie is bad, 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 and says that word 5 times. Now, generally for sentiment, maybe we don't care how many times a particular word occurs, we just care whether that word was in there or not. So that thus this simplistic model of just a 0 or 1. But you could do frequencies. You could also do weights. So maybe we think that the word the has very little weight, but the word disappointing has much higher weight. Or you could construct other kinds of strategies for weighting as well. So there's a lot of complexity here, or a lot of options to do things differently. So now once we have all these feature vectors, we can put this into our data matrix, often called X. It has columns for all of our vocabulary, all the unique words we've seen. We have rows for every document that we've seen in our data set. Generally, we want many more rows than we have columns. So if you're looking at vocabulary that's even modestly sized, so 2,000 to 10,000 unique words, then you want 2 to 10,000, or hopefully 20 to 100,000 different documents or samples. So you can learn some information about this and about these words. Again, we'll use the binary version of all these documents, whether they include a particular word or not. And then we have some label vector, generally denoted as Y, which tells us here we're just using 1 or 0 for positive or negative samples. And sort of the core kind of machine learning task is we have this label vector, we have this data matrix X, and we have some weight vector W. And we want to learn some W, or identify or construct some weight vector that when you multiply this data matrix times the weight vector, you get a set of predictions, Y, and we want to minimize the difference between what our actual values, our actual labels are, and then whatever our predicted values are. So this delta between Y and whatever our predicted Y is. A lot of machine learning sort of boils down to coming up with this W in a reasonable way, and how we want to weight incorrect kinds of labels, or what kind of loss we want to use for comparing the real labels and our predicted labels. So there's just too many ways to do machine learning here to discuss them, but this is the general kind of task. But text classification is sufficiently common in social media analysis that there's good examples or good tutorials to walk through. The Natural Language Toolkit has one that's just about supervised classification. Python has scikit-learn, which has a lot of classification and machine learning models built into it. But the general process for this is you train some machine learning model on some set of your training data that has the input X and your label Y. You extract some features. For us, our features are the words and the vocabulary, and you learn some model on it. Then when you have some new message, some new tweet, some new movie review, etc., you tokenize it up, extract the features that we've seen before, specifically, or at least critically, only the vocabulary words that we've seen before, and apply our learned model to it to predict some label. Like I said, this is sufficiently common. I've provided some code for this. This is a modification of what's in the NLTK textbook. Now, as I mentioned, there are other ways that we can featureize this data, other ways we can look at how this data might be created. So the first one the one that I've shown here is the binary feature vector, where each one tells us that that particular feature exists in our sample. Certainly you could do count features, or it's called count vectorization, where each element indicates the frequency of a particular token in a particular message. Or you can do other things like TF-IDF, so count feature vectors, you could also call that term frequency. IDF means inverse document frequency, which allows us to weight tokens by how unique they are. Tokens that occur in many documents, so things like stop words, the word the, and, I, he, she, maybe these kinds of things that you'd expect to be extremely common, should have very low weights because they appear everywhere. Whereas tokens that appear very rarely in very few documents should be weighted more highly. So the TF-IDF weighting metric lets us do that. So what I just showed you was the more classical way of doing text mining, where you have some feature vector for a message that tells you how often an individual token appeared in that message, or whether an individual token was in that message. But over the past 5 to 7 to 10 years, a new approach for doing featurization of text has come up called embeddings. And actually this comes up and has become popular in many different places, from graph embeddings to word embeddings to image embeddings. And the idea here is we pre-specify some column counts or some dimensionality. Generally, this is low, so tens to hundreds, rather than the vocabulary size of thousands to 10,000s to 100,000s, where these embeddings represent something about the context of words. So I won't go very deeply into this. I'll just say that oftentimes what you do is you just find the average embedding for a sentence or for a message, or you find a way to embed a whole message into this low dimensional space that's generally dense, and then you use that as your feature vector for doing your task. What I mean by dense is, you can imagine if we're talking about tweets and we have a vocabulary of, say, 10,000 words, that an individual tweet probably doesn't cover more than a handful of maybe 10 to 15 words. So for a given sample in our data set, the vast majority of columns are going to be 0. Here with embeddings, you try and make that much more dense and much lower dimensional, and avoid some of the issues with machine learning that come with really high dimensional data sets. If you want to talk more about this, by all means reach out to me and we can have long discussions about how embeddings generally improve text analytics. But even with all of this, measuring sentiment is still hard. So just because we have more sophisticated methods for doing featurization or more sophisticated models of learning sentiment, we potentially still have to deal with like thwarted expectations or sarcasm. So even the best models still aren't going to be right all the time. So how do we evaluate performance here? Well, it depends on the task. If we're looking at trying to recover these 5-star reviews or like numbers of stars of reviews, then what we have is some prediction task where we have text and we want to predict the number of stars, 1, 2, 3, 4, 5, right? So then we can evaluate this using mean square error, where we take what the actual number of stars are, subtract off what our predicted number of stars are, square it, and then take the mean across all of our samples. And that tells us something about how well we're able to recover this score. For the case as in movie scores, or you just care about positive or negative sentiment, then we can treat this as a classification problem with just 2 classes. And we can talk about true positives, which is the number of samples that have the positive score. So here there are 2 true positives, and there are 2 true negatives, or the number of negative samples. And when we talk about true positive, true negatives in performance metrics, these are generally things that you got correct. How many positive samples did you actually label as positive? How many negative samples did you actually label as negative? But then you have the flip side, right? So you have false positives, the number of negative samples that you got wrong, things that were or should have been labeled as negative, but you incorrectly labeled them as positive. So that would be, in this case, saying that the most aggravating kind of movie was actually saying that this was a good movie. So that would be a false positive. And then you have false negatives, which is the flip side, the number of positive samples. So like the first 2, I don't think there's anything in this film that doesn't work. If you said that that was a negative review, when it's actually a positive review, that's a false negative. We can talk about accuracy as the number of things you got right. Of the samples in the data set, how many of them did you get correct? So oftentimes in the case of classification, you have very different kinds of distributions of data, where you have very few positive samples and many more negative samples. So for the movie review case, this maybe isn't the case, because people might be just as likely to post a bad review as a good review. But you could imagine, in my case, in doing crisis analytics or crisis informatics, we're looking for tweets that express something about search and rescue, that, well, people asking for help, or the police to come save them, or the fire department to come help them, would be very rare in the overall sort of online discussion, right? So in that case, we have maybe just a handful of search and rescue tweets for a given event that may have thousands or tens of thousands of tweets. This is called the class imbalance problem. And here, in this case, you care less about just accuracy, because accuracy being high may only tell you that you got all of the negative samples correct. So you can get more specific in the kind of metrics. One is called precision, which is the number of things or the number of positive samples that you got right over all the things that you declared were positive. So this is essentially noise. So if I want to show you, here are all the things that get this label, how much noise or how many times would you expect to see something wrong in that set of positively sampled things? And then you can contrast that with recall, which is of the things that were positive, how many of them did I return? So this is basically a coverage question. Like if there are many positive samples and I only return a few of them, then my recall would be low. But you can manipulate this by returning more content, right? So how do you get perfect recall? You return everything and say all of our samples are positive samples, because I don't get penalized for false positives. I get penalized for missing things that should have been labeled as positive. So ideally, you want to provide some way to balance these, or in your task, you want to specify which one you care more about. So for the crisis informatics question, we actually care a lot more about recall. Anytime somebody posts something about a search and rescue request, we want to capture that. And if our emergency responder has to review some noise or see some noise in order to get all of the search and rescue tweets, maybe that's not a hugely bad thing as long as the noise isn't too bad. But maybe you want to balance the two together. So how do we do that? The general approach is to use the harmonic mean here, and this is where the F-score comes from. I won't say anything more about these metrics than that, other than these are ways you evaluate your systems if you're trying to do some classification problem for text, which maybe you could be doing for your project. But if you have any other questions about how you might evaluate some text classification problem, let me know or reach out and we can discuss. I haven't discussed other aspects of sentiment using emojis, but there's definitely research on that. So I mentioned that emojis can be a significant signal. How do we incorporate that? There's research there. Likewise, I've only really talked about sentiment as this attitudinal question. There is definitely a lot of work on trying to infer or identify emotion that's expressed in a particular message, but that's complicated. One approach, so for emotion, there's the same kind of question about Lexica versus machine learning models. Saif Mohammed from the National Research Council in Canada has a nice lexicon for this called EmoLex that's been used to answer questions about how people's emotion and sentiment have changed. So for example, if you want to understand how emotion and sentiment towards the police changed following a terrorist attack, you could look for social media content that mention like the Boston police following the Boston Police Department or the Boston Marathon bombing. There's a lot of psychology work about emotion that you can then rely on. So like there's, for example, there's Plutchik's Wheel of Emotions that tell you a lot of relationships between emotions. Mohammed's emo lexicon identifies words that are associated with each one of these emotions. And then we can look for messages that include these kinds of content. But I'm telling you all this to say, well, this is a thing that you might want to do, but you should be very careful here. So, for example, in this case of sentiment towards and emotion towards the police, here's a number of tweets in the lead up to the Boston Marathon bombing. And what we see is a significant spike in both positive and negative sentiment. And it turns out partially this is because words like police generally have a sentiment attached to them that is often negative, which makes these questions complicated. Because this means that if any message that includes the word Boston police is going to immediately have some baseline sentiment associated with it because it includes the word police. So this is a reasonable task you may be interested in doing, but you should be careful when you try and apply these sort of lexica or try and evaluate how people feel towards a particular target when that target itself could have some underlying sentiment towards it. From a learning objective perspective, we've talked about several content mining tasks, from figuring out most common or frequently used hashtags and keywords, and sentiment mining. We'll talk about more next time. I've described sentiment analysis to at least some significant detail that you should be able to describe what sentiment analysis is, what we're measuring, and ways that it could be measured. I've defined precision and recall, so you should be able to at least review this to get a sense of what these different metrics are trying to capture. And you should at least be able to go through and implement a sentiment mining task or a sentiment analysis task at this stage. Though we'll talk next time more about other kinds of analyses you may do. All right, next week we'll talk about topic modeling. I'll go into a similar level of detail here. I'll introduce and define named entity recognition to give you a sense of the task. We'll talk more about geolocation and using content mining for geolocation. And then we'll talk a little bit about image mining as well, to give a different kind of sense for things that are not just text mining. All right, and I'll post a couple of discussion messages. And if you have any other questions, by all means, post there or reach out.